Okay guys, welcome back to part 2 of our video over exponential functions. Today we're going to focus on writing exponential equations in the form of y equals ab to the x. Remember, a is the initial value, or in this case the initial amount or y-intercept if you were graphing. B is our growth factor. We also discussed this last time as being a multiplier, and it is still our multiplier. I also want to discuss the difference in percent growth and the percent growth or decay in the growth factor. When we are discussing how much something is growing or how much something is decaying by looking at the growth factor, we need to do a subtraction problem. So if we have decay, we want to take 1 minus our growth factor, and that difference is going to be the percentage of decay. And if we have a growth, we want to take our growth factor minus 1 and find the difference to find our percent of increase or percent of growth. Remember, we talked about the growth or the b value always being positive, but we need our percent of growth or decay to always be positive. So I think it'll make more sense when we look here in these examples here right here. You have an initial value of 2 on this first problem, and then you have a growth factor of 1.2. So what I was just alluding to as whether or not you're going to subtract from 1 or take your growth factor minus 1. When I see that we have a growth because our b value is greater than 1, we're going to take 1.2 minus 1, which gives us 0.2. Now that right there is not a percent, that's just a number. To convert that to a percent, we can either move the decimal place 2 places to the right, or we can multiply by 100 to get 20. Either way, one's just moving it to the right 2 places is just a shortcut. We'd be able to say that there's going to be 20% growth. Okay, so this one here is a percent growth because this was growth. B value is greater than 1. All right, let's look at our next example. In our next example here, the initial value again is 2. Our b value is 0.75, so that's just our growth factor. We see that it's less than 1, so since it's less than 1, we want to take 1 minus our growth factor. So 1 minus 0.75, we get a 0.25 times 100, and we get 25. So that means we have 25% decay. Okay, so they align with each other. If it's decay here, then it's a decay factor. If it's decay factor, then you're going to have a decay for your percent of growth or decay. And this will become even more important when we look at some word problems, because they're going to ask for not necessarily the growth factor, but they'll be asking for the percent of growth or decay. Okay, so I already kind of covered this in the last 2 examples, but if we're going to convert a percent to a decimal, we need to divide by 100. So in some of our problems, they will tell us the percent of growth or decay, and we need to convert that into a decimal. So if they tell us that it's that we have a 25% growth, okay, and we want to convert that to a decimal so we can add it or subtract it to 1 to get our growth factor, we would need to convert this to a decimal. So if we divide by 100, we get 0.25. So 25% as a number is 0.25. If you're going from the decimal to the percent, so if I had 0.25 as my number and I wanted to convert that into a percentage, we would multiply by 100 to get 25%. Okay, now when we talk about percent increase, percent decrease, okay, so if we're trying to find the growth factor, okay, or decay factor, we're going to need to take that percent decrease or increase and convert it into a growth factor. So if it's a percent increase, we want to add that to 100. So for example, if we have a 20% growth, we're going to add that to 100. So we would have 20 plus 100 is 120. But to get that growth factor, we have to convert that to a decimal by dividing by 100, and we would get 1.2. So that would be our growth factor. Okay. Now, if we have a percent decrease, so if I'm reading a word problem and they tell us that we're decreasing by so much, let's say we're decreasing by 35%. Then I need to find my decay factor. And so to do that, we're going to take 100 minus 35, and these are both percentages, and that gives us 65%. Okay, now if we divide that by 100, we get 0.65. So this is our decay factor. All right, so multiplier to percent growth or decay. We would subtract 1, then multiply by 100. So when I look at this example here, y equals 1.0, y equals 5 times 1.05 to the power of x, we see that b is greater than 1. So if we took 1.05, and this is very similar to the previous examples that we have done, we would subtract 1, giving us 0.05. If we multiply that by 100, we would get 5. So it would be 5% growth. Okay? Now, if our growth factor starts off as less than 1, so in fact it would be a decay factor, we would take 1 minus 0.35, which gives us 0.65. So times 100 would give us 65%. Okay, so be very careful in situations like this. They may ask you, how much is it decreasing by? It's not decreasing by 35%. It's decreasing by 65%. Okay, it's how much is left. And so if we take away 35, then, or if 35% is left, then 65 is what we were taking away every time. All right, so let's just go through a couple examples here. Determine the initial growth, or determine the initial amount and the percent growth or decay. This might be a good time to pause the video and try these on your own from what we just talked about. So if you'd like to do that, you can go ahead and do that now. If not, let's move forward. So initial amount would be 450, and the percent decay would be 48%. I know it's decay because 0.52 is less than 1, and if we take 1 minus 0.52, we get 0.48, which is 48%. In our next example, the initial amount is 100. In this case, we're going to have a percent growth of 26%. And I know that because 1.26 minus 1 is 0.26, which would then convert to 26%. All right, just one more quick example. Your initial amount here is 12, and then we have a percent decay. Again, because our b value is less than 1, so if we take 1 minus 0.865, then that would give us 0.135, and so that is going to be a decay of 13.5%. All right, let's move on to writing an equation given some scenarios. So this is what I was alluding to a little bit. They're going to give us an initial amount, and then they're going to give us a percent increase or decrease. They will not always use the terminology percent increase, decrease. One real world example here is the word appreciation. The opposite of appreciation is depreciation, which is what a lot of items that we buy do, is they depreciate in value. That means they decrease in value after we purchase them. But if we're just going to write an equation for the scenario, the initial amount, $210,000, it is appreciating at 4%. So if it's appreciating, it's increasing in value, you know your B value has to be greater than 1. And if we take 100% plus 4%, so 100 plus 4, we get 104%, which is 1.04. Okay, so that would be our equation. We have 10,000 bacteria in a colony that grows at 23% per hour. We don't need hours, it's per hour. So we would have 10,000. It's growing, so 1.23 would be our multiplier. Okay. The value of a motorcycle depreciates. So we have a $14,000 motorcycle and it's depreciating. All right. I see a lot of students write 0.14 right here. Okay. If you're losing 14%, how much is left? Okay. So we're going to take 100 minus 14 and we get 86. And so if we can divide this by 100 to convert it into a percent, we get 0.86. So if you're losing 14%, then your value is worth 86%. So 0.86 is our multiplier, our decay factor. All right, now we have some stock. It is doubling. And so for something to double, we have to multiply by 2. And so essentially this is like 100% plus 100%. And so that gives us 200%. All right. Just 2 more examples here and we'll be done. So let's look at some just real world scenarios, very similar to what I just gave you. Look at our second to last example. In 2000, the world's population was about 6.09 billion. During the next 13 years, the world's population increased by about 1.18% each year. Now, the initial amount in this problem is going to be our 6.09 billion. And I'm just going to leave it at 6.09. We're not going to write that out in billions. To find our multiplier here, be careful not to use that as your growth factor. Remember, whenever they give us a percent of increase or decrease, we need to add that to 100. So we want to add 1.18 to our 100, which gives us 101.18. And if we convert that into a decimal, okay, because this is a percentage, if we divide it by 100, we get 1.0118. So this is our growth factor to the power of x. And it wants us to estimate the population in 2005. Just remember, they told us we're starting in 2000. So in 2005 would require us to plug a 5 in for x. Now I would suggest using your calculator when you're doing this. One way to do this would be to go to your table, and I actually already have this equation in the calculator. Let's make this a little bigger. I think I already have the keyboard here, or the LCD here. So if you're looking, if we hit second graph, then you see we already have some data in this table, and we want to look at 5 years. And so we would not want to look at 2005 because we understand our data is starting in 2000. So that tells us that 6.4579 billion So I would say just 6.46. Okay. Now, part B of this wants us to estimate when the population of the world would be around 7 billion. So again, if we go back to our calculator, we can scroll down through the data. It wants an estimation, not an exact. So we see between 11 and 12 is when it jumps from the 6 billions to 7 billion. And so we would say approximately 11 to 12 years. All right, so one last example, and this might be a great opportunity for you to pause and try this one on your own before I move forward. If you want to do that, go ahead. If not, we can keep going. The value of a car in thousands of dollars can be approximated by the model 25 times 0.85 to the t, where t is the number of years since the car was new. So tell whether the model represents growth or decay. And so we should be able to recognize that it is decay. Why? Because the b value is less than 1. Okay, so we have 0.85 is less than 1, so it's decay. Identify the annual percent increase or decrease. Well, we know it's decay, so it's a decrease. Be careful not to say a decrease of 85%, because it's not losing 85% of its value. It's losing 15% of its value. And we find that by taking 1 minus our growth factor, or in this case, decay factor, and we get 0.15. And if we multiply that by 100 to convert it to a percent, then we're going to get 15% decay. Okay? And then part C, it wants us to estimate when the value of the car will be $8,000. Again, I would go to my calculator. If you don't have your TI calculator at home, don't forget you have Desmos that you can use, and you can slide your finger on the line. It'll give you points, and you can approximate that out to 8,000. So we're going to take 25, and I said 8,000, but remember our value is in thousands, so that's 25. At 25 is in thousands. So we really just want to look for when it equals 8. So if we hit second graph and look at our table, we can see around 7 years. Okay, so approximately 7 years. Okay, guys, I hope this video found you well. If you have any questions, don't hesitate to email any questions you have. Hope you have a great day.